Hey everyone, welcome back. Today we are talking about wire management. So wire management, or good wire management, I should say, involves a few key factors in my opinion, and those are good fit and function, longevity, safety, and tidiness. Let's talk about each of those and then how we'll bring them together in our builds. When I say good fit and function, what I'm referring to is that your wires are conforming and fitting into your chassis and or your saber, and if they must move in and out of position when you're accessing a battery, a recharge port, an SD card, etc., that they allow enough slack for easy access, yet they return to their in-hilt position without causing a hang-up. Longevity. That simply means that both your wires and their solder joints are well placed, well made, and well protected so that they can last as long as possible. Safety is not just for you, but for your components too. And this involves good planning and double checking your work to ensure that you do not allow substandard wire management to ruin your hard work via a short circuit prone situation. And tidiness, the mother of them all. That is something that you should not compromise on, whether it's for price, simplicity, speed of install, or anything at all. I'll give you some ideas and inspiration on how to achieve these things, and then I really hope everyone will share their own ideas and techniques in the comments with any other questions or discussion that you guys would like to have. So, first up, let's talk about chassis because that really comes into play when you're talking about wire management. The slam dunk option for removability from the hilt is a one-piece, fully removable chassis. Oftentimes those chassis not only come all the way out of the hilt, but they offer ease of access to all of your components. Obviously, you still need good wire management inside the chassis, but you don't have to concern yourself with loose wires that are routed into the hilt between your chassis and other components. Closely related, but the next best option probably, is a chassis that is permanently or semi-permanently mounted into the hilt. And then part of the hilt acts as a cover that can be removed to allow access to the SD card, the battery, recharge port, what have you. And then the next most common is probably one that houses at least your board and battery, maybe a speaker or a recharge port or other components as well. But it's tethered to other components in the hilt via a wire bundle. And that setup, in my opinion, is the least convenient, much less convenient than a fully removable chassis or one that's mounted yet accessible. However, sometimes it is necessary or convenient for the installer or the installation space. So, to give a little bit better illustration of what I mean, if you haven't seen each of these chassis options, I do not have the chassis on hand that I was referring to, but a fully removable chassis would be as simple as you take off the pommel, or oftentimes the lower end of your saber, and then the entire chassis would slide out of the hilt, and it takes with it all of the components, or nearly all of the components in the hilt that are electronic. A permanently mounted or semi-permanently mounted is usually secured to the front end of the hilt, but when you take off the back or the back half of the hilt, so say we take off the pommel and this portion here, in this case, a chassis that is mounted into the hilt yet accessible would probably stick out about this far, have the battery, a recharge port, and your board accessible at the very least. And then the option where your wire is tethered in between and you have to slide the chassis in and out to access it would often be via the pommel removal. We would just remove this portion here, and then there would be wires tethered to a chassis, and that chassis would then slide out of the hilt to allow access to a recharge port and your SD card. Not to downplay the importance of wire management inside the chassis, but the loose in-hilt wires need to be given even more care because they are typically the most vulnerable and potentially problematic. So let's take a look at a few different ways of handling wires throughout those install styles. And starting off, we'll look at wires that are just freeballing in the hilt, so to speak. This bundle is going to work best if it can easily return to its position in the hilt without interfering with the fit of the chassis or other components, as well as not posing a risk of breaking joints when doing so. Let's talk about how to achieve that. First, consider your solder joints. So let's look at the recharge port. We've got solder joints here, and we'd have a board and battery down here. There are solder joints at either end of this wire bundle. You need to relieve the stress on those joints caused by the motion of your wires when you're moving the chassis in and out of the hilt. Because what's going to happen is the wires are going to bend in the middle and they're going to push against the solder joints. You can see here, I have heat shrink, and that is one way to relieve some of the stress on those wire joints. You'll notice with that heat shrink on there, they don't bend at the joint, they bend out here in front of the heat shrink. Another way on some components is to add a small dab of hot glue, okay? You would just put a small amount here prior to adding heat shrink or after adding heat shrink, and then you would do your wire twist. You do not want to add a lot of glue. It doesn't matter what kind of adhesive it is or what kind of tape it is. Always use just enough. The same goes for E6000. It's another good option. You would just apply a small amount of it to keep those wires together. And again, that would mitigate bending at the joints. That is not the method that you're necessarily going to use on all of your components, but you'll get a feel for what you like to do after you have completed a few installs and tried a few different methods. Personally, I often use heat shrink only. If there's a situation that arises where there is a more vulnerable joint, I might add glue. The add-in there is that the way that you will route these wires and the way that you twist them and bundle them is going to relieve a lot of that stress as well. Also, the direction in which you face the wires from the joint will help. So, segueing into that, when you put this recharge port in your hilt, if you face it back towards your board, when you slide the chassis in and out, the wires coming from the board and the battery to this recharge port are going to press into those joints, and the wire is going to want to naturally bow out more, and so it's not going to conform to the space in the hilt very well. However, if you turn this around and make a gentle U-bend underneath that recharge port, when you slide your chassis in, the wires are naturally going to not only press away from these joints and keep the joints safe, they're going to go into the hilt deeper and they're going to conform better to the space in the hilt, allowing your chassis to slide in properly without interference with the wires. The same goes for your joints down on the chassis end of the build, where they come to the battery and especially the board. When you're sliding that in and out, you're going to see the same type of resistance and force against the joints down here. Okay, so you're going to want to secure these wires in some fashion to the chassis so that it relieves the stress on the joints. An easy way to do that is having a chassis that has properly designed wire channels and routing those wires through those channels so they don't have anywhere to escape or to bow out, and then putting a small amount of adhesive onto those wires if they are stressing those joints. And then the wire runs between those joints. It needs to be formed to move in and out efficiently. There are a few ways of accomplishing that, and we've already talked about adding in a bend like this underneath your recharge port or your switches or whatever components you may have in the hilt, because then the wire is going to more easily move into the hilt away from the chassis. You're going to want to twist the wires together. Now, the way I do it is I take one component and I twist the wires from that component together. And then I go to my next component and I twist those wires together. Okay, say these are switches. And then I'm going to go to my NeoPixel module, okay, and I'm going to take the wires from that. I'm going to twist them together. Now you'll see some people will like to braid, some will like to wrap. I prefer a twist, and the way that I do it is I pinch the wires at one end, and I begin to pinch and twist, and pinch and twist. And while I'm doing that, I'm letting them slide through the fingers on my left hand. And you get a nice tight twist that way, and those wires are not going to come back apart as easily as if you were to just wrap them. I prefer this over a braid simply because a braid is a little bit looser generally, and I feel like a braid takes up a little bit more space sometimes. It's also more time consuming to braid your wires. It seems unnecessary to me, but some people prefer it, and I'm not going to tell anyone that they shouldn't do it. You need to try out different methods and see what works for you. So now I have those wires twisted together. I have 3 bundles of wires here. Depending upon the size of these bundles, you could twist these bundles together, or you can simply give them 1 or 2 twists around each other so that they loosely move together, but they're not tight together, right? They still have some independent movement. It's all going to depend upon the space you have in your hilt and how you need to form those wires into the hilt. But the way that you get them to stay inside the hilt like you want is to create bends, strategic bends in these wires. Some people like to create a coil, like a spring, okay? So let's say this is mounted on the hilt. Coiling would be wrapping this wire in this fashion so that it looks like a spring. And then when your chassis goes in and out of the hilt, those wires will naturally want to go back to that shape, and they'll push into the hilt and they'll bunch up flat. Another method that people like to use, S-curves. So you go one way and then the other way, like this. And it's very similar to coiling them like a spring. It's achieving the same end result. Again, whatever works for you and your installation space is what you'll want to use. Those are just a couple of methods that I would recommend. If you need your wires to stay in place better or maintain that shape better, the best way that you can achieve that is to heat them up. So what I mean by that is you can take a hairdryer even, or a hot air station, or a heat gun, or a lighter if you don't have those options. And you're going to warm up the wire, all right? And then you're going to form it into the shape that you want it to keep. And with it formed into that shape, heat it again and form it a little bit tighter into that shape. And then hold it in that shape until the wires are completely cool. And what this does is the heat makes the insulation a little bit more malleable. And when you hold it in position until it cools, then it's going to retain that shape better that you placed it in. Smallest insulation possible is really helpful. This is PTFE. PTFE is the smallest insulation that we often see used in saber building. Another common one is PVC, which is much larger, but about the same rigidity as PTFE. And then right in the middle is silicone. And silicone is very, very flexible, but it is a little bit larger than PTFE, and it's not quite as durable. So if you want something that's going to easily move into the hilt, silicone's going to work for you, but silicone doesn't hold its shape as well as a more rigid insulation will. So I like to use PTFE because it holds its shape fairly well as long as you don't stretch it out straight and taut. And it's also smaller, so it takes up less space in the hilt. Another important thing, cutting to length, because you're looking for any way to reduce the amount of space that the wire coil is going to take up, right? So if you only need 75% of this wire here, you're not going to leave that entire length. You're going to have this in its place in the hilt. You're going to bring these wires out the bottom end of the hilt to whatever portion of the hilt you need to have the chassis at to install those wires. Then you're going to trim them to length and solder them to the board or your battery or whatever component down here that's relevant. And lastly, we're going to talk about the wire in your chassis. It should not stick out. It shouldn't interfere with fitment of the chassis into the hilt. The same should go for any of the components on the chassis. Yes, I know this chassis has nothing to do with the saber. They were just a couple of empties that I had laying around that were convenient for giving a presentation here. So let's say you've got your wires coming down into the chassis here. Okay, we'll just put one bundle down into the chassis. And then let's go ahead and put a board there for illustration purpose. So these wires come down here, they go to the battery, into the board. When you wire up your board, those wires are going to be best suited to come to the underside of the board because they're less likely to come up and off the chassis and rub against the hilt or the threads of the hilt when you're taking the chassis in and out of the hilt. If those wires are rubbing constantly against your threads on the hilt or the edge of the hilt as it's going in and out, the insulation on them is going to wear down and you're going to create a short circuit scenario where if the bare wire touches against the hilt or against another component, then it could fry your electronics and you don't want that. So very important wire management tip there. Don't allow any of your wires to be in a situation where they're going to rub off the insulation. If you have to solder them onto the top side, which often happens, what you need to do is make sure that you route them underneath the top level of the chassis. Because if they come above the top of the chassis, again, they're rubbing on the inside of the hilt and you're going to lose your insulation and you're going to create a short circuit. Different ways to achieve that are, again, heating those wires up so that they will conform better to a space. Say you have a wire soldered down here on this end of the board. You could warm that wire up and route it flat along the board and then bring it over the board and down inside of the chassis. And then secure it with a very small dab of glue down in the chassis or against the chassis. That way those wires can't bunch up and touch against the hilt when the chassis goes in and out. Another way to secure not only your wires, but your board is to use heat shrink or tape. This is just like with adhesives. You do not want to use any more than necessary. This is Kapton tape. This is an anti-static tape. You can see it's got a yellowish tint to it. I believe this is 1 3/8 inch roll. It's right about the size of this board. However, when you put tape over a board, you do not want to cover any of the larger components on the board. You'll see these black boxes. You do not want to cover any of those components because those components get warm when the board is functioning. And there's more on this side. If they are in direct contact with a surface and there's not air getting to any of them, they can heat up excessively. I'm not going to say that I've never installed a hilt with something touching or over some of those components. But it's best if you can avoid it because your board's going to receive the most efficient cooling if nothing is over the top of those. And then, again, you're looking at longevity of your components. The board is going to last longer if you keep those components cooler. A good way to tie a board down if you don't have any other option, you would place heat shrink around the chassis or tape around the chassis in strips where it doesn't come in contact with these larger components. You could put it in between where the buttons are here, down here where the USB port is at, or over the SD card here. That's going to be slightly different locations depending upon the board you're looking at, but still the same principle. If you have a tape or a heat shrink over your board, and your chassis is very close to the inner diameter of your hilt, chances are when you put that chassis in and out of the hilt, you're going to rub off that tape or that heat shrink, or it's going to tear. So keep in mind that if you want to do it that way, you're going to need to have either a chassis that is smaller than the internal diameter of the hilt, or you're going to need slots that are designed to use that kind of mounting. The optimal scenario is where the board is held tight into the hilt by retention on the sides. Most well-designed chassis are going to have board retention built in, so you're not going to need to hold the board down in that fashion with tape or heat shrink. However, they are options. Some chassis are built so that the board slides in the end, and that's even better. Another method you'll sometimes see, even coupled with board retention occasionally, is putting a dab of E6000 or hot glue on the corners or edges of the board, just to give it a little bit more extra security, so that on a very hard clash or swinging, you don't see the board detaching from the chassis. Any motion of the board off of the chassis can stress the joints of the wires if it's continuous. Again, with your chassis, it's good to have your wires cut as short as possible so that there's not space being taken up down on this end. And when you're trimming these wires, you need to be mindful of the fact that the wires go to certain components, and if you have no way of identifying those wires, or if you're getting rid of your way of identifying them when you trim them, you need to keep in mind which ones go where. So some things that I have done, you can see these wires have some different colored stripes on them, or you can get solid colored wires. That is the easiest way to track what components your wires go to, and that keeps your installation tidy and it keeps you from making mistakes. What you'll do is you'll get your colored wires, you'll keep a sheet next to you where you have probably drawn out a rough schematic of your hilt and your chassis, and then you have labeled the colors of wires and drawn them to whatever components they go to. And then you have soldered them to the correct components in the correct locations. Another way that I have done it, and that I still often use, is using only one color of wire. Sometimes it's nice to have all black in your hilt or all white in your hilt, just depending upon your color scheme and if you want your wires to blend in completely and be invisible. And the way you handle that is you need to have some way of identifying which wires go to which component and which ones go to which pads on those components. So you have 3 bundles here, okay? You know which components those go to. This goes to your recharge port, this goes to your LED module, this goes to your switches. But once they're installed in the hilt, and all you can see are these bare wire ends coming out, if they're all the same color, you have no idea what components those go to likely. What you can do is when you trim them initially, trim your switches long. Trim the recharge port right in the middle, and trim your LED module shorter, but leave enough length on all of them they can still be easily installed. So here's your installation length right here, but then you leave them past that length, and then you note on the description of your install what length goes to what component. Then the individual wires can be trimmed to different lengths in the same fashion, and you note which one goes to which pad or which terminal. Or this does take up a little bit more space, and you run the risk of the label falling off if they're roughly handled, but you can take a small piece of tape and write a label on that tape and attach it to each individual wire to tell you where that wire goes to. So those are just a few ways of organizing your wires when you're installing. There are, I'm sure, a million other ways that people do it. Those are just ways that I have used. Another thing to be mindful of is keeping your wires towards the inside of your chassis, okay? Even if it's not just your board. Say you have your recharge port down here, or you have your battery down here, or your speaker. The best place they can be is right smack in the center of your chassis, because then they can't rub against the hilt. if there's no extra length on them, and if they're adhered or tied down to the chassis or held in wire-specific channels, they're unlikely to bunch up inside the chassis. All right, guys, so that about wraps it up for today. Keep in mind that you need to tailor all these tools and methods to your needs. Every install and installer is different. We won't all do things the same, but we should all give ample consideration to the methods we use. Ask your questions down below in the comments or bring them over to the Saber Builders Academy. I'm going to link that group in the description as always. And always feel free to tag me if there is a question specific for me, but there are plenty of people there who are going to be answering your questions just as well as I can. Thank you guys for watching and have an excellent weekend.